Okay, it's time to begin. Today, we're going to use the rational zero theorem. Okay, you can see up here, I did put an example up here at the top. Remember, in this particular case, A's of n would be this 4. This n would be that 3. N minus 1, meaning the next lower powered number would be A's of n minus 1, whereas that one's n minus 1 there. If that's n minus 1, 3 to 2. Here we have n minus 2. 3 minus 2 is first power. So this 32 is the number that goes with that first power. And that's the way these read. Until finally you get down here where you have the either a 0 or a number which becomes your y-intercept. The constant on the end is always your y-intercept. Now, what this is saying, as long as that's not 0, the first number right here, okay, which is kind of a lame disclaimer. But what this says, if some fraction in lowest terms is a 0 of this, meaning it's a true value of x for that equation. Now, what this is saying is that p is a factor of this constant, and q is a factor of that 4, or the leading term value. Okay? Now, that's what this rule is saying. So what we're saying in general is that if we want to know some 0 of that, by looking at this number, the factors of 15, positive or negative, 1, 3, 5, and 15 itself, and the factors of 4, 1, 2, and 4, using those numbers, we can explore all the possible zeros that could work for this problem. Now, just because they could doesn't mean that they will. And we have to test that by using either synthetic division, long division, or just ordinary factoring, or the quadratic formula. Okay. If there is a rational, meaning fractional 0 for the polynomial, remember when it says if there's a 0 for it, that means is there a root? Anytime you see the word 0 used in this context, you could substitute the word root or x value. Then it must be of the form all of the factors of the constant over all of the factors of the leading term. Now, if the leading term's 1, then it's easy. It's just what are the factors of the constant on the end? It has to be one of them. I gave you a clue to this the other day when I gave you an example saying, well, if it were a certain number, then this number we're trying would not be a possibility. Okay. There. Okay, all the possible zeros of this. We do have a leading term, so we've got to consider that, and we got the 15. This is the same number that equation I had up there a few minutes ago. So first we look at all of the factors of negative 15. Well, and we're going to look at all the factors of 4. Let me raise this back up. Come on. Okay. Just keep getting lower and lower. All the factors of negative 15 are a positive negative 1, 15, 3, and 5. We've been doing this forever when we were doing factoring by looking at the A and the C terms. Likewise, the factors of 4, as I said a few minutes ago, are plus or minus 1, plus or minus 4, plus or minus 2. Now, the implications of this is you could have x equals 1 or x equals negative 1. You could have x equals 15 or negative 15. Or you could have this 1 over this 2, or x equals 1/2 as a possibility. So any possible combination of those would potentially be a 0. Now, will all of them? Absolutely not, okay? At most, there can only be 3 of them. Okay, so here we go. There are those numbers. Here are all the possible sets of factors. Good, finally decided to go up. All of these whole numbers obviously would work. Then we've got to consider these whole numbers divided by, in turn, each of these. Now, if we have the 1, okay, 1 over 1 is just 1, so it's covered back here. 1 over 4 would be 1/4, plus or minus. 1 over 2 would be plus or minus 1/2. I usually list these in increasing order, left to right. It just makes it easier not to make a mistake for me. Okay, then we go to the next top number, 15. Well, 15 over 1 is 15. 15 over 4 here. And then 15 over 3 reduces to 5. So we don't need to write that one down. And then 15 over 2 is here. Then we come to the next number, 3. 3 over 1 is 3. Okay. 3 over 4 is 3/4. This 3 over the 2 is 3/2. So that's all the possibilities there. Then we go to the 5. 5 over 1 is 5, so it's already included. 5 over 4 here. 5 over 3, 5 over 2 is here. So what we've got, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 2 signs of each. We've got 24 possible sets of zeros that we might look at. Well, you want to go smarter, not harder. You don't want to try all of them. You want to try some that are a little more obvious if you can. Well, let's go on to the next problem. Here, list all the possible zeros and their multiplicities. It wants us to actually find them. Oh, here we're just going to list them. So in this case, we've got our 8 produces 1, 4, 2, 4, and 8. And all of these are plus or minus. Then that 4 on the front produces 1, 2, 3, and 4 itself. Now, given those, 1/1 is just 1, so our total list is plus or minus 1. Okay, 1/2, we got plus or minus over 1/2. 1 and 4, we've got plus or minus 1/4. Now we move to this 2. 2/1 is 2. And 2/2 is 1. And I've already got it. 2/4 is 1/2. And I've already got it. Now we move to this 4. 4/1 is 4. Okay. 4/2 is 2. And I've already got it. 4/4 is 1, and I've already got it. Now let's move to the 8. 8/1 is 8, plus or minus. 8/2 is 4, I've already got it. 8/4 is 2, I've already got it. So in this case, this would be the full set of possible answers we could attempt if we were going to try to do that problem right there. Now, obviously, I'm going to do probably plus or minus 1, plus or minus 2 as the first ones that I do, simply because they are simple. And I've got to find an eraser. The instructor that's in here before me, there are boards on 3 walls of this, and he moves his computer around to different boards and covers all 3 boards during classes. And he leaves the erasers wherever they happen to be. Unfortunately, all the other boards are blackboards, and then I put these up for whiteboards. Okay, here we go. Now, we've got to actually find the zeros, not just the possibilities this time. So the factors of 3 over the factors of 2. Here's the 3, there's the 2. Gives us this, which gives us that set of possible factors. Okay? I'd suggest you write these down before we move on to the next screen. I'll give you a moment. All right, now we're going to continue to the next screen. Here is the original equation. We had a 2, 1, -5, -1, 0. So that's what this is here. Okay, 2, 1, -5, -1, and 3. Okay, now we're going to try +1 because +1 was one of our possibilities. So we're going to try that fairly easy one. We could have tried -1 just as easily. So we're going to try +1. We bring down the 2, we multiply, we add, we multiply, we add, we multiply, we add, we multiply, and we get a 0. If you recall, if we get a 0 remainder, that means that this truly is a solution. In this case, x equals 1 or x minus 1 as a factor. Okay, and hopefully I can just leave that there. So we've got this, and what multiplicity is it going to be? It's going to be a multiplicity 1. Okay. Well, actually, we don't know that yet. Let's go ahead and try the next step. They're going to try 1 again on this divided answer. They're going to take this answer, okay, and now they're going to try +1 in it again. I guess I better get that out of the way. So we take this one down, and we're going to try x into it. They're showing the factor that I wrote over here again. Well, here's your bring down, multiply, bring down, multiply, add down, multiply, add down. And so in this case, we got a true 0. So that means that x minus 1 will go into that original equation twice. Okay, or at least twice. So right now, at the very least, we have a square there. But it may or may not go again. Now, let's see what we've got. Remember, this is now, we started with 4th power. This became 3rd. This became 2nd power. So we've got x squared, 2x squared, plus 5x, plus 3. And that thing, we can either try a 1 or a 3, and also divide it by a 2 as possibilities. Now, what are the factors of this thing? Well, we've got x minus 1, and we've got this so far. Well, will this break down further? X minus 1, and this factors into 2x plus 3 and another x plus 1. Okay? Now, usually when it gets down to x squared, then we try not to go ahead and do another synthetic division. Then we usually try to factor it if we can, and you would use 2 over 1, and in this case, 2 over 1, and then 3 over 1 would be your factoring lines. So we got these 3, our 4 terms. This one becomes a 3rd power because we've got x minus 1. Oops, that's x plus 1. So that's a 2. And we've got x minus 1, or x plus 1 as a factor. And then we've got 2x minus our plus 3 and 2x, x. Well, we've got that, okay? We've got 2 of these, 1 of those, and 1 of these. This one is a 2nd multiplicity, a touch and go. These 2 are both, in this case, single multiplicities. Now let's go back to our graphing the other day. Okay, we've got x equals 1 right here. We know that it's a touch and go. We've got x minus 1 right here. We know it's a crossing. We've got 2x plus 3, but we've got to simplify 2x plus 3. Okay, so 2x plus 3 equals 0. Take the 3 over. 2x equals -3. Divide by 2, divide by 2. X equals -3 over 2. Okay. Well, 3 over 2 is 1.5. So it would be right here. Okay. And since there's only one of them, then it also would be a crossing. Now, this thing started out as a 4th degree. So that means it's got to go up and up because the leading term was positive. So this is going to go up like that. That's going to go up like that. The only other thing that we could do is look at the y-intercept on the original equation, which was 3. 1, 2, 3. Right here. Okay. This one's a touch and go, so we know it's got to come up like that. These two are crossing, so this thing's going to come down like this. We don't know how far, and then back up. To get how far, we'd have to take -1.25, halfway between these 2 points, and solve for y using that equation. So this is what we would look like, and this is ultimately what we're trying to do. We take an original equation, 2x to the 4th plus x to the 3rd minus 5x squared minus x plus 3, and we break it down 1 degree because this becomes, okay, this was x to the 4th, x to the 3rd, x squared, and x. This one becomes x to the 3rd, x to the 2nd, x, and constant. Right? Here, this becomes, and I've already got it written out for you, x squared, 2x squared, 5x, 3. Then we can factor this one and get our 4 zeros, our possible roots on this problem. That's what this whole business is about. That's why we studied synthetic. That's why we studied long division. You could do long divisions with these too, but I think you see it'd be a whole lot harder than doing the synthetic. So that's what this process is about, is taking the original down 1 degree using that rule based on this constant, the factors of the constant, and the factors of the leading term to give you values to attempt. So let's go on to the next slide. Okay, find the zeros and their multiplicities again. Same sort of a problem. Let me get rid of my scribbles. Okay, we've got a 1 up here, so that means that that q term is just going to be 1, so it's going to be a non-factor. So the only thing we have to worry about for possibilities are the factors of 1 and 5. Okay, and they are 1 and 5, plus or minus. So now we're going to try positive 5. Okay, and we get a 0 remainder. So yes, this is true. So now we have, instead of x cubed, we have 1x squared plus 3x That's a plus there. Plus 1. This we might be able to factor, except that won't factor. That thing won't factor, it's prime. So what do we have to do on this one? We have to use the quadratic formula to find the other zeros. We've found 1 0 for this problem so far. The 0 we found is x equals 5, or in factor form, x minus 5. Okay? Now, let's go on. Okay, that just says that. And it says now we've got this. So they're bringing this equation over here. Let me erase my scribbles because they're going to be in the way. Besides, it says the same thing right here, except I'm going to put on here also the factor x minus 5. Okay, so what you can see, they're putting it into the quadratic formula like I told you you would have to. So we take negative b plus or minus square root of b squared, or 3 squared, minus 4 times a, which is 1, times c, which is 1, all over 2 times a, which is 1. Okay? That simplifies to 3 plus or minus square root of 5 over 2. Okay? And those are your actual values. Now, you could simplify this a little bit. Okay? The way you could simplify this is you could change that into negative 3 halves plus square root of 5 over 2. Now, square root of 5 is 2.232. Okay? Approximately, because it keeps on going. Then you can have negative 3 minus square root of 5 over 2. You might ask, well, how would you graph this? Well, we would replace this with that, which would give us negative equals negative 1.5. That's what negative 3 halves is. Plus this number divided by 2. Well, 2 goes into 2 once, decimal point. 2 goes into 2 once. 2 goes into 3 once, with 1 remainder, and 2 goes into 12, 6. Okay? And keep in mind, this keeps on going. If we add this to this, we get a negative, well, keeping in mind that that's a negative. So what we would have to do, and I'm running out of space, is 1.116 and 1.500. This one is negative. Okay, so you subtract the little one from the big one. So 10 minus 6 is 4. 9 minus 1 is 8. 4 minus 1 is 3. 1 minus 1 is 0. So in your graph, then you would have, if here is 1, then you would have a point about 4/10 of the way. Then we'd have to do the same thing. And as you see, this would be kind of a pain. You'd want to use this in your calculator instead of doing it by hand like I did. If it told you to graph it, but it didn't. Okay. Now, The main thing that they're wanting to show you out of this problem is simply the fact that, once again, because that's a 1, we took the factors of this, okay? And we took it down 1 degree. And then we were to a square, and we would never guess square root of 5 as part of our answers. But notice that 5 and its square root of 5 located in this, that's not a coincidence. Now, we use the quadratic formula to take it down from the 2nd degree, and then we were able to tell this. Now, because with the plus and with the minus, these are 2 distinct answers. Each one of these is multiplicity 1, and this x minus 5 is a multiplicity of 1. Okay, we could try this one. In this case, our possible are going to be plus or minus 1, plus or minus 2. Okay. I'm going to try positive 1. No, because that's negative on the end, I'm going to try negative 1. So I've got 1, minus 1, minus 4, minus 2. Bring down the 1. I get negative 1. You add those, I've got negative 2. I got negative 2, or positive 2, which gives me 2. And that gives me negative 2, which is negative 4. Okay, because I made a bad guess, I did not get a 0 here. So negative 1 is not a root of this thing. Well, let's go back and try again then. And let's try positive 1. Bring down the 1. 1 times 1 is 1, you get 0. 1 times 0 is 0, you get negative 4. 1 times negative 4, you get negative 4, and here you get negative 6. So you know what? That's not going to work either. I'm bad at guessing today. Well, let's try a 2 and see what happens. Okay, bring down the 1. We get a 2. That gives us a positive 1. We get a 2. That gives us a negative 2. And we get a negative 4, which gives us a negative 6. So that one won't work either. Well, what about this? Okay, bring down the 1. Gives us a negative 2. That gives us a negative 3. This gives us a positive 6 there, which gives us a 2 here. And that gives us a negative 4. Well, in this case, this isn't going to break down. Unless I made an error somewhere. Because we've tried all of the possibilities. Okay, let's double check them. Here I get a 1. Here I get a -2. That gives me -3. And I did write the original problem correctly. Okay, -3 times -2 is +6, gives me a +2. And that gives me a -4. So that one is correct. Let's go back and check again, this time with +2. Bring down the 1. We get a 2. That gives me a value of 1. I get a 2. That gives me a value of a -2. And that gives me a value of a -4. Okay, so no, that did not work. Okay. Whoops. Negative times negative is positive. Okay, I made a mistake on the very first one I tried. I don't know where my mistake was because I've since erased it. So what this is telling us then is this thing breaks down into x squared minus 2x minus 2. Okay. So far we got x plus 1, x equals -1. Okay. Now this thing we can either factor or we can use the quadratic. If we tried factoring it, we'd have to go with something like this, and that's 1, and these are different signs, so we would subtract them, we would get a 1 out here. So in other words, that tells us that this isn't going to factor. So the only way we have left to do this one is we can use the quadratic formula. So x equals -b, which is -2, plus or minus the square root of -2 squared minus 4 times a, which is 1, times c, which is -2, all over 2 times 1. Okay, this gives us 2 plus or minus square root of 4 minus or plus 8 all over 2. So we get 2 plus or minus all over 2. So we get 2 plus or minus square root of 12 all over 2, which is 2 plus or minus 2 times square root of 3 all over 2. How did I get this? Because this is 4 times 3. Okay, the 4 will extract to 2, leaving the 3 under the radical. Now I can change this into 2 over 2 plus or minus 2 square root of 3 over 2. Cancel those, and I get 1 plus or minus square root of 3. Okay, now that would be, in this case, our root, or our x value, and these are going to be two different distinct ones. So each one of these is going to be crossing. The -1 will be a crossing. And this one, what do these two break down into? Well, here I have 1 plus 1.732, and this is something you'd want to do on a calculator, which is 2.732. And this one, the minus side of this, I've got 1 minus 1.732, which would be, in this case, 8, 6, 9 minus 7 is 2. Okay, would be -0.268. What would this thing look like as a graph? Okay, we've got -1/4. Here's 1. Here's 1. Here's 2, 3, -2, and so on. So we've got 1 point there. This one, 2.73212, and about 3/4. Okay, this one, we've got -1 right here. Okay, the original equation is a cubic with a positive first sign. So we know that this has got to go like this, and that's got to go like that. And both of these 2 points, okay, this point right here has to be a crossing point because there's only one of them. So what that means is this thing is going to go up and down and then back like this. Well, actually, it won't go that far down. Here's my spacing. There's 1, there's 2. It'll go down to -2. And then like this. So that's what that graph would look like, tying it in with what we did before. Now, what did we do? With a great deal of hassle, we took this thing down 1 degree. Okay? After we got it down to 1 degree, this thing wouldn't factor. So we had to use the quadratic formula to get the other 2 zeros. So we have x equals -1, x equals -0.268, and x equals +2.732. Okay. That one was kind of a pain. So was the last one. And as you see, it's very easy to make a mistake like I did on that first one. I don't know where I made the mistake. Here's another one. We're going to skip over that one and that one. Actually, maybe we will do this one. This one's got some missing terms. It's got a missing x cubed and a missing x. Okay. We probably have maybe 1s, 2s, 4s, 5s, most likely in that one. Okay. Now, the fundamental theorem of algebra. Fundamental theorem of algebra says if you've got a polynomial with complex coefficients, okay, that means if you've got imaginary values in front of your x's or x squares or whatever, or x cubes or whatever, then it says you have at least one complex zero. Now, there's also a rule that's going to tell you if you've got one complex or imaginary A plus BI number, then you have to have its conjugate. They always come in conjugate pairs. Okay. And what this is saying is, well, this is just saying that if you've got this, then you've also got that. Okay. So if we had one of them, we had to have two of them. Likewise, you noticed earlier when we had the square roots, we always had two of them, conjugates. Okay. If you have imaginaries, you'll have its conjugate. If you have a conjugate, a radical, then you also will have its conjugate. Now, at that point, we're going to stop right here. It's almost time. I won't even have time for the next problem that we have. And so we're just going to go on. So I'll see you on Monday. There is no class tomorrow. Kennedy, hang on for a second. And everyone else, will see you on Monday. I'm going to turn off the recording.